Hello, everybody. Today I'm very happy to present my paper on the fifth International Conference on the Intelligent Systems Designs and Engineering Applications. And the topics of my presentations today is about the beyond accuracies a comparative analysis. Sorry. Of interpretable and transformer-based models for mental health classifications. Some introduction and motivation for the paper in the context of today we see social medias provide a vast real-time window into public mental health. But there are many challenges for psychiatrists, like psychiatrist language is highly nuanced and overlapping. And also datasets suffer from self-class imbalance, abundant for depressions, post. Some people they share their feeling the test in a social network. And the rare post for personality disorder. So we see the class imbalance. So the paper would like to pursue the objective to provide a comparative analysis of modeling approaches to solve this imbalance. And we're thinking of for the okay the relation between accuracy and interpretability. So in data analysis, we often think of the criteria for related to the accuracy. So I think of the other way beyond accuracy. So we propose the methodologies with three tiers comparisons. You can see on the diagram here on the right, we have the raw data from the social media statements. Then go to the first step for processing, highlight, lower casing, noise removal, negation handling, tokenization, and lemmatization. And then we print out to, like I said, to engineering techniques for hybrid feature engineering. Vader sentiment analysis. So we adopt the pre-trained model to define its negative, neutral, or positive compound. And we also have the others way for ITF vectorization, unigram by grams, and then combine together with concatenation the features. And the important thing, we handling the imbalance causing with most on training data. And the outcome with the logistic regulation and error. Lastly, evaluation and explanation with classification matrix and explainable AI. And on the left are of the slide, we see we compare three distinct approaches: the baseline logistic regression, LR, TF, IDF vectorization, and the second improved LR framework integrate various small result class imbalance, and last one small spurs. Okay, it's a SOTA, is robust pre-trained transformer model, so that it's a state of the art. Uh, and we use the data sets to make the demonstration for the models for the architecture we propose previously. With data set comprised social media data set from public data set Kaggle, and the size is over 34,000 samples. We have 7 classes: normal, depression, suicidal, anxiety, bipolar, stress, personality disorder. And we also reprocessing, for noise removal, tokenizing, worknet lemmatization. And with the output we have here, we pay also accuracy, weighted F1, macro F1. For the baseline, improve is SOTA per. We see it here. Okay, so SOTA per is at the highest, and for all numbers, yeah. We say improve for our logistic regression model in the middle, and the baseline on the left. So we come into the comparison for performance overall. So the baseline struggle heavily with minority classes. The sports and Vader grammatically push the minority recall. The small pro achieve the highest overall metrics. So some kinds of overviews of the results. And refer to performance comparison, we have the confusion metric. We have a metric review where models succeed and fail. And noted the distinct in the misclassification for minority classes, improve logistic regression framework compared to baseline. All right. Trial accuracy and interpretivity. Small bird achieve high accuracy but act as a black box. But as say AI is explainable AI, we apply alignment strips to improve our model. So the model provide clear insight with the feature directly. We could see the coming up outcome here. For example, for the okay, we see with the predict for depression and also for anxiety. We can see the waiter neutral on the left with the red, so it means positive, and it's negative, positive on the right with blue, and negative on the left. So when we see some, we can get whether that spot is the depression. We have consider, okay, they have the rule like nothing, a few hopeless alone here. Yes, etc. And also have the same group aside for Vader negative. But highly is with a low, harmless, hopeless, some kinds of. So if we should care for accuracy, okay, we can get high accuracy, right? But it's hard, it's black spots, it cannot explain for the user what does this mean and how the model got that the output. So this paper, we could love to present an insight that okay, accuracy is worldwide to choosing which model over the other model. But refer to explainables, if we can thinking of the way to open the box. Yeah, as I'm here, we see on the right, here is a anxiety. So we see the highest, okay, the word here. Wow, anxiety and also have neural. You see, for the pre-trained model of Vedas, they totally in neutral. Yeah, for society. Yeah, and some of the other example we got from this paper with from normal. You see, what normal is that okay? The video is so neutral, normal, and also have the word normal. All right, normal is Saturday, persons, great. It's something great, even great. Okay, but the video, right? Compound, video positive. So it is really taken out from the pre-trained model, and we see that okay, somehow it's normal. Normal is look like it can explain okay how the model they dealing with and how to see the prediction going on the behind the past the suicidal. So you see suicidal they have okay some very negative words on the social network posts, and the positive the other side is okay, something like this, the neutral. Yeah, had everything positive. You see the neutral and positive and negative. It's all of them. So they opposite, right? Opposite is the negative for suicide. It's not suicide, but you see it is negative, include positive also. It's kind enough information for us to consider. But from here we have more information inside whether the word they come from, maybe one and everyone, something for anyone, everything. So it's the way it's complicated, right? But you see, we here we have a lot of related word have the high score. So, so we can see the future deployment of mental health classifier. Okay, we should compile fairness constraint to prevent system make bias. So the trading of between the strict predictable accuracy and equitable detection, I mean here across demographic and conditional times. So in some kind for mental health, it's very difficult. It's very fuzzy. It's very complicated. So yeah. And some conclusion we got from a paper is class imbalance in mental health and it can be effectively mitigated using sports and center feature engineering as an example for the result from our paper. And also we're thinking of okay, we maybe we something some time to trade off. Okay, trade off between the prediction powers with high accuracy with the choosing from transparencies of the model that can be explainable, interpretable for the user, for therapists or psychologists, some kinds of. And coming in this future world, continuous working for algorithm for fairness aware to directly into the training loop and exploring domain specific for the field. Yeah, LLM. We apply for machine learning AI, which what people talking about and topics, yeah, and pure in interpretability, some kinds of these coming up. And I think that's it's a song for my presentation for the paper. If you have any questions, drop me the email. Thank you.